In this video, we will go over the basic configuration and setup of an AKCC 750 case controller on an AKSC 255 rack controller. The first thing to make sure of when programming the case controller is that the proper files are loaded into the 255 rack controller. To do this, we will first make sure we're authorized from the main menu. When proper authorization has been entered, you will see that reflected in the top right corner of the authorization screen. From there, we will go down to the configuration menu and into file management. Once in file management, we will go to device files, where you will see a list of EDF files which are used to translate data from a given case controller into the 255. For the AKCC 750, our file number will be 080Z0130. If you do not see this file listed in the directory, it must be loaded in using the AKA65 software. If you do see that file in the list, you can highlight the action column, which will give you a drop-down list where you can look at the info on that file. The info includes the name of the file, again 080Z0130, as well as the version and the date the file was created. If you have an older, out-of-date file, there is a chance you will not see all information for a recent case controller, or the information being viewed may be incorrect. To date, our current version of the AKCC 750 case controller is version 5.5. Once you've confirmed that you do have the proper files, you can then return to the main menu. Again, go into configuration, and this time we will go into refrigeration. If this is a controller that already has some programming on it, you may see racks configured already. If not, you can click on Add Rack at the bottom of the screen and change number of suction groups to 1. Once this has been completed, we can go to the previous screen. And we want to go down to evaporators. Again, if this is a controller with some programming that already exists, you may have some circuits programmed. In this case, we do not, so we will change number of circuits to 1. The next step in setting up the 750 case controller will be to make sure the type column for this circuit is set to generic. If it is not, you can highlight the option that is selected, hit the edit key on the keyboard, and drop down to generic. Once this has been done, we will then go into the setup button. Once we're in the setup of this specific case, we're initially asked for type and name for the fixture. These two are for reference only. The final option on this screen, multi-evap controller, must be set to yes. If it is set to no, later screens will only show options for single evap case controllers which do not include the AKCC 750. With this option set to yes, we can then page down to the next page where you will be able to bring up another drop-down list that allows you to choose from various case controllers. The options in this list are reflected based on the file management screen that we looked at when we were talking about EDF files. In our case, we want to choose the AK-CC750-055X option. You also notice with each selection there's information given at the bottom of the screen. In this case, the part number 080Z0130, which matches the EDF file we previously looked at. And then we also get the software versions that this file corresponds to. With that selection made, we can then go into the setup of the case controller. Once in the setup of the case controller, if the address of the case controller is known, that will be entered in at the top of the screen. If it is not known, it can be left at 0 for now and entered in at a later time. At this point, if the 750 has already been configured through the service tool, you can go out of this screen, bring the case controller online via a rescan, and then return to this screen to upload the settings. That will update all screens in the 255 to reflect what has been programmed via the service tool. If no programming has been done ahead of time, or if the address of the unit is not known, we can then go through each screen individually. At the top right corner, you will notice a series of bars with double arrows left and right. If you do not see these options, that means that the access level that you've entered in is not high enough to allow you. Current versions require at least a refrig all access level or higher. Older versions of the 255 required a supervisor level access. The next setting that is crucial to the programming of the 750 is the main switch. When we are initially programming the case controller, we must make sure the main switch is off so that any settings we change or adjust are accepted by the 750. The main switch will be turned back on at the conclusion of the programming once normal operation is to proceed on the case controller. The user file mentioned at the top of the screen can be used to reference a file that has been created to hide certain settings that are not necessary for a specific setup of the 750. This makes programming easier from a viewing standpoint. To cycle through the various screens of the 750 through a computer, you can simply click on the double arrows in either direction. To accomplish this from the keypad of the 255 directly, you must press the Shift key and then the arrow keys in the left or right direction depending on which page you are trying to get to. With our main switch off, if we proceed to the second page of the setup, our next step is to make sure our configuration lock is unlocked. At this point, we would want to program our number of evaporators. That can be anywhere from 1 through 4. And then drop down to our quick setup parameter. If the board and points of the sensors and relays have already been assigned through the service tool, you will not want to make any selections here. However, if the layout of the sensors and relays has been done in such a way that it matches up with one of the quick setups here, that does not require the service tool, and allows for a single choice to be made that will assign all the boarding points at one time. The user would have to know what each setting for the quick setup corresponds to in regards to the I/O layout before making this selection. In this case, we'll choose the 4EEV-LT option. And you'll notice you get a pop-up window indicating that the setup may take a few minutes to apply to the 750 and to press 1 to continue. Typically, once this setup has been chosen and has been applied to the 750, you will then be prompted in the 255 if you want to download all other settings to the 750 or not. You will only want to do this if you have already programmed your defrost settings, your temperature settings, and your other miscellaneous settings for lights, fans, etc. If you have not done this yet, you will not want to program or download to the 750. Once the quick setup has been applied, we will then proceed back to the first screen, where we must make sure our main frequency and refrigerant type are selected. Again, if the main switch is not set to off, the selections made for these two options will not be accepted by the 750. Below refrigerant type, we select our thermostat type, where we are choosing if we are controlling a single valve for multiple evaporators, or if we have individual valves on each evaporator. On the first screen, we are also setting our dew point control for our anti-sweats. This can either be done via a setting from the 255, which broadcasts the dew point to the 750, or it can be done using a timer function. When using the timer function, cycle percentages are set for daytime and nighttime for the anti-sweats, and for dew point control, a minimum and maximum range are set. Also on the first screen, we select if we are using lighting control or not. This can be accomplished through the day-night schedule of the 750, through a unique schedule from the 255 specific to the 750, or it can be via a door switch which comes from a digital input signal that is tied to the 750. If we then page over to our second page, we'll again see settings for number of evaporators, our valve type, which is either going to be a liquid line solenoid valve for relay control or an 8 kV expansion valve for pulse control. And then our refrigerant type and our main frequency. On the fourth page of the evaporator setup, we begin to get into the thermostat settings for each evaporator. Page 4 is for thermostat A, and we begin by setting the control sensor for the refrigeration. This can either be the return air sensor, discharge air sensor, or a combination of the two. If we only want to use the discharge air sensor for control, our discharge percentage setting just below that must be at 100%. If the user wishes to use return air only, this setting should be programmed for 0%. Any combination of the two would correspond to some value between 0 and 100. Once this has been set, we then drop down to control temp and control temp differential, where we are setting the target temperature for the case and the deadband. Once this information has been entered in, we then program the ability to alarm based on case temperature, at which point we again choose if this value will be based on the return air, the discharge air, or some combination of the two. At that point, high temp and low temp settings are entered in, each with their own time delay. You'll also see a pull down delay setting, which is used to initiate a longer delay when a higher low temp time delay that is timing down enters into a defrost. This will account for the defrost itself. Pages 5, 6, and 7 are the thermostat settings for evaporators B, C, and D. You may only have 1 or 2 evaporators configured on the 750, but you will still see thermostat settings for all 4 evaporators. You simply do not need to set the settings for the evaporators that are not being used. Starting with the 8th page of the setup, we begin programming the settings for superheat control if we are using an AKV valve. We begin by enabling injection control to tell the 750 we are doing superheat control through the AKV valve, at which point we program minimum and maximum superheat settings. The 750 will try to maintain a minimum stable superheat within this range, while also trying to maintain case temperature. Below that we have a superheat close setting, which if we drop down to a superheat below this value, we will shut the valve down to 0%. We also have high suction safety settings in the 750, such that if suction temperature gets above a certain value, we will also shut the valves down. The final 3 options on this screen also give you the ability to manually override the valve, be it an AKV or a liquid line solenoid valve. To do this, for the AKV, we would change the valve control from auto to manual, and then enter in the opening degree we wish to see on that valve. If this is a liquid line valve, we would simply go to manual on or manual off, since this is using a relay and not pulse control. Screens 9, 10, and 11 are again for evaporators B, C, and D. Again, if we are not using all 4 evaporators on the 750, we will simply not program those options on the other evaporators. Screen 12 would be where we configure our defrost options. Here we set if we have defrost control, and if so, what type. Each selection in the drop-down list will enable or disable relays that are designated for the defrost control. Defrost control on the 750 can either be done via a common defrost relay or via individual defrost relays for each evaporator. Below this we have options to manually start and stop defrosts, and then where our defrost will initiate from. This can either be done from an internal schedule in the 750 or over network schedules that are entered into the 255 program. Below that we set our defrost failsafe interval so that if the 750 does not see a call for a defrost over a certain period of time, in this case 24 hours, it will automatically generate a defrost signal to begin a defrost. This is used as a safety feature to back up the scheduled defrosts in the 750 to ensure we are having defrosts. Typically we will set the defrost failsafe interval to 1 hour beyond the standard range between two defrosts that are scheduled. For instance, if we have 3 defrosts scheduled a day, at 8-hour intervals, our defrost failsafe interval would be entered in for 9. We then have the option of setting the fan to run or to stop during defrost, and termination of the defrost. This can be accomplished via time, individual temps on each evaporator, or a common temperature. The temperature that is used to terminate can either be the coil outlet reading from the 750, return or discharge air readings from the 750, or a dedicated coil temperature reading for each evaporator. Below that, we set the target temperatures for the termination on each evap. This screen also gives us the option to set the maximum duration of the defrost, as well as any pump down or drip delays we may want to enter in. Pump down will shut down the AKV for a certain amount of time before energizing any defrost relays, and drip off will hold the AKV from opening up after the defrost is terminated. We also have the option for fan control based on the defrost, where we can delay the fan for a certain period of time or until a certain temperature has been reached on the coil. The final option in the setup of the defrost for the 750 is the adaptive defrost mode. This option gives the user the ability to enable a setting that can either add or remove scheduled defrosts based on various readings in the 750 for energy savings. For this mode to be utilized, 4 things must exist on the 750. The coil outlet sensor, the return air sensor, discharge air sensor, and an AKV valve must be used. The AKV valve is used as a flow meter. The coil outlet and return and discharge air sensors are used to create calculations that determine if there's ice buildup on the coil or not. With skip day or skip day night selected, defrosts that are scheduled for the 750 can be skipped. The fully adaptive option in the 750 allows for defrost to be added on top of scheduled defrosts when necessary. The next to last page in the 750 setup is for common functions. This includes anti-sweat control, lighting control, and door switch control. You'll notice the anti-sweat control has the same settings as the first screen in the 750 setup. This does not need to be set again if it already was. Lighting control was also on the primary screen and also does not need to be configured a second time. For the door switch mode, we have two options. We can either use the digital input to alarm only, which will not affect any of the functions in the 750, or we can use it to stop injection, which will close down the AKV or liquid line solenoid valve. This feature will also disable the lights in the case or walk-in after a programmed delay set here for 2 minutes. This setting can be changed anywhere from 0 minutes to 60. We also have a door fridge restart delay, which gives the user the option to program a set amount of time after which refrigeration will restart on the circuit regardless of whether or not the door switch is still open. So in this case, after 30 minutes, the door may still be open, but refrigeration will begin again on the case. Below this, we set our alarm delay. So after 30 minutes, an alarm would generate from the 750 into the 255 to notify the user that the door is still open on this circuit. When in a shutdown mode based on the door switch, we also have the option to determine whether fans and lights remain on or off or in computer control. Our final option on the next to last screen of the setup is for manual control of the fan for testing or other purposes. Again, using the edit key, you can see you can either turn the fan manually on or manually off, which will toggle the relay on the 750. Our final screen shows our master control or MC functions for the different relays that the 750 is controlling. You can use this screen to override the different functions in the 750. This is typically used as more of an information screen that reflects the current state of each relay, as well as the state of the dew point reading that we are getting from the 255 to be used for anti-sweat control on the 750s. Once this 750 has been programmed, we then determine if we want to push these settings to the 750 now or if we must wait until a later time when the case controller is actually online. To push the settings to the unit now, we will click on the download button at the bottom of the screen. Make sure the circuit we want to apply these settings to has an X in the box to the left, and then click OK at the bottom. Multiple circuits can be downloaded to at the same time if they are selected on this screen. The upload function is used when the user has programmed the 750 from the service tool and has not changed anything in the 255. This will extract settings from the 750 and populate those parameters in the 255 configuration. It's important that you do not do the upload if your settings have already been pre-programmed through the 255 settings we've just reviewed. I'll now go back and set up a second evaporator so that I can show you how the copy function is used. So we return to the main evaporator screen. I'll now set my number of circuits for 2. Again, our type must be set to generic, or else we will not be allowed to choose the 750 case controller for the circuit. We'll go into the setup. I confirm multi-evap is set to yes for the controller type. I page down where I choose my version 5.5 of the CC750 case controller. With the second evaporator configured, I'll now return into the setup of the first evaporator that was already programmed. And proceed to the copy button at the bottom. What this feature does is allows me to take all the settings from the first 750 that I set up and copy them into other evaporators that have been set up on the 255. This can be any number of evaporators as long as they are also set up for a 750 and set up for the same software version, in this case the version 5.5. If a different version is chosen, that will not show up on the copy screen here. So we'll again enable the checkbox to the left under the select column, and we'll hit OK. At that point we get a pop-up screen that notifies us that the settings are only being transferred into the 255 itself. If you wish to push these settings down to the 750, you must then go back and do a download on the other units that you've copied these settings to. So in this case we will press 1 to continue. At that point our new settings would be in the second evaporator. Then we could then return to the download button where we can check off the checkbox for the second evaporator. And we'll hit OK. And that downloads to the unit. When downloading, you'll notice at the bottom of the screen there is an update status that lets you know that information is being sent down to the 750. Once this download has been completed, you'll get an operation successful that tells you everything went through okay. If for some reason the download was not successful, you will see an operation failed message here. If the download was successful, you also notice back at the top of the screen that the time and date of the download are time stamped. This gives the user an indication later on of when the last download on that case controller may have occurred. Unknown typically indicates that there never was a download sent to the 750. Next to copy is our alarms button. Here we will configure the alarms that the 750 will allow to filter through to the 255. As you'll notice, there are 14 pages of alarms. In most situations, we only need a few of these alarms, so we will actually click None at the top of the screen, which will disable all the alarms that are in the 750. At that point, we can then filter through the pages and only enable the alarms we truly want to show up on the 255. It may be a good idea to set your alarms up before copying to other units if you are going to use the copy function, as the alarm setup can also be copied over to other 750s. The final two buttons on the 750 setup begin with the extended configuration menu. Here, the 255 allows us to import data from the 750, be it a sensor reading, opening degree of a valve, or a pressure transducer reading. We can take these values and use them for other functions in the 255, such as calculations. When choosing the parameter you wish to import from the 750, it's important you then choose the proper units on that input. Each 750 allows you to import up to 16 data points. The RW, or read-write configuration button, gives the programmer the option to save the settings from a specific 750 into his computer, and then later on use those settings to download to another 750 all in one shot. This does not have to be on a 750 that is in the same store or on the same controller as the one that they are saving the file. This can be saved to a computer and then loaded into another 750 later on down the road. To back up the settings to the computer, change the action type to write, and then give the file a name to identify it by. Once you choose to go back and use this file to load into a 750 setup later on, you would choose the read action. And that will give you a drop down of the configuration files that it recognizes on the computer. You'll notice the top of the screen indicates the directory in the computer where these files are being saved. We will now go in and look at a live unit with 750s configured on the rack. Again, from the main menu, we'll initially go in and verify that we have the proper files loaded into the controller. So we'll go into Configuration, File Management, and then Device Files. We are prompted for a password if we have not entered one in yet. On a live unit, when connected from a computer, you'll notice at the top of the file management screen there are two options, local or 255. Local would show you the files that are located on the computer itself, whereas 255 would show you the files that are located on the 255 controller. When viewing a 255 from a computer, the files must be located in both locations to properly view the 750 setup. At that point, we can now drop down to the first EDF, the 080Z0130. We see that it does exist. We can go into the info screen, verify. We have a file here. The top half of the screen shows the version that is in the 255 controller. The bottom portion of the screen shows us the file that is on the computer, as well as a directory that that file is located. You'll notice here the two files are not the same version. It appears the file that is in the 255 is a newer version than that is in the computer. If we wanted to, we could return to the file management screen. And again, under the action column with 255 selected at the top, we could do a read. This would allow us to extract the EDF that is in the 255 back into the computer and overwrite the older database or older EDF file that exists there. Similarly, if we have local at the top and we looked at the same EDF, if the version that is in the computer is newer than the version that exists on the 255, we could do a write option. This would write the EDF file into the 255. It's important when reading or writing files between the computer and the controller that the systems are reset or restarted after the files have been transferred. We'll then page down and verify that we do indeed have the device.lst file, and that is located both on the computer and on controller. From here, we'll return to the file management screen and go into device management, where we can page down and verify that the 55X version of the 750 is enabled. We'll now return to the main menu of the 255 controller and look at some of the status screens that we can see in the case controller once it's been configured and brought online. First, under Communications, and then I/O Network, you'll see an Overview option. Under Overview, we have a generic button that we can click on. And this screen gives us data, which is feedback from each of the case controllers that are actually online with the 255. None of the information you see on the screen is reflected based on any programming whatsoever. So here you'll see the address that each 750 has been assigned based on the rotary dials on the front of the cover, the device type, which corresponds to the part number of the 750, the model of the 750, in this case the 55X, and the software version that that corresponds to. This is a good screen to view when verifying case controllers that have been set up and attempted to be brought online are indeed online. This screen can also be used to verify the software version that is being selected in the 750 setup matches the software version that actually exists on the 750 that's installed on that address. Once this information has been viewed, we can then return to the main menu. From the main menu, we'll go into Refrigeration. We'll select the rack that we want to view the 750 case controllers for, and we'll go into Evaporators. Here you'll see a listing of the different evaporators that have been set up for Rack A. Again, you can page down if there are multiple pages of the case controllers. Under the address column, you'll see different formatting of the addresses based on the type of circuit that's being controlled. In the case of the lowboy freezer on this program, addresses 02-1.2 and 02-1.4 correspond to standard AK2 modules, so we are not using the 750 case controller here. Circuits A3, A4, and A5, however, have a single-digit address followed by a single letter, which corresponds to the current state of the case. This type of format does indicate that the 750 case controller is being used. You'll notice the address is duplicated for some of the circuits. This indicates multiple evaporators. So in the example of A3, we have 2 evaporators set up for address 1. The target temperature for each evaporator is displayed in the far right column, and the current temperature reading, which again can either be the S3 sensor for your return air, the S4 sensor for your discharge air, or a combination of the two, is displayed under the current column. We then go forward one screen and click on one of the evaporators. We then see a status for the evaporators that are only relevant to that 750 case controller. We again see our temperature readings, the address of the 750, and then a brief description of the current state of the case. Adaptive SH or adaptive superheat indicates the primary concern of that valve and that evaporator is maintaining a superheat setting at this point. You may also see modulating here, which indicates that the superheat of the case is okay. And we're at that point primarily concerned with the case temperature itself. You may also see thermostat cutout here for situations where the case temperature has been met. And you'll also be indicated for defrost states or offline if the case controller is not communicating with the 255. From here we can then go further into the 750 by clicking on the evaporator we wish to view. Here we again have our bar set up in the top right corner with the double arrows, which allows us to toggle between different sets of readings. At the bottom of the screen you can see we can also use the F3 or F4 options to toggle back and forth between measurements or values that the 750 is reading, or F4 for settings where we can view the current settings in the 750 and then we can also adjust them from there. We'll look at measures first. On the first screen we're given an indication of whether there are any errors, which would correspond to any alarms on the 750, and then again the regulating condition of each evaporator. No cooling on regulating conditions C and D indicates that we are not using those two evaporators. We also have feedback here as to whether or not our fan relay is on, whether or not our anti-sweat relay is on, and if we were using a dew point value from the 255, what that value is right now. Our final measurement on this screen is the status of the light relay. Our second screen, again, shows the regulating conditions on the evaporators that are in use, and also indicates if we are in a night status or a night setback state at this point. Night setbacks are used for alternate set points on the cases. Third screen shows us temperature readings and relay states that are relevant to the thermostat control of the 750 for the first evaporator section. Here we can see our control temperature, which again could be discharge or return air or a combination. And then our cut in and cut out temperature targets. This takes the temperature target and the dead band from the set points to correlate to a cut in and cut out. An NAN value for any of the sensors indicates that sensor either is not being used or is not properly reading at this time. For this evaporator, because the control and discharge air sensors match up, that indicates that we are only using discharge air for control. As we scroll further down on this screen, we will also see the current reading on the alarm temperature that's being used for control. The bottom portion of the screen gives us information on the current runtime of refrigeration on this evaporator, the runtime over the past 24 hours, as well as the temperature reading that is being used for alarming. Again, this is based on return and discharge air sensors. The final screen gives us the superheat or injection values relevant to evaporator A. As we scroll down, we know we are not using liquid line solenoid here, we're using an AKV valve. So it shows us our current opening degree of the valve. It also indicates the average opening degree over the past 24 hours. And then it gives us our saturated suction temperature, which comes from the pressure transducer that is landed on the 750, converting that pressure to a temperature, as well as the temperature on the outlet of the coil from a temp sensor. These two values are used to calculate the superheat. Which is compared to min and max superheat settings for the control of the AKV valve. If we then click on settings, we'll see the information on the screens varies. We're still on the fourth bar at the top, so we'll scroll back to the first. These are some of our primary settings as far as refrigerant type, thermostat type. Here you can see we have an individual valve for each evaporator, and we're using an on-off control method for the valves. This programmer is using a melt function, which actually shuts off refrigeration to the case every hour for 5 minutes to simulate a mini defrost, basically to help prevent ice buildup on the coil. And we are not using anti-sweat control here. As you'll see, the settings initially have asterisks to the left of them before updating with the information that is actually coming back from the 750. As long as the asterisks remain to the left of the values, you can assume that that setting is not what is currently in the 750. Once the asterisk goes away, that will be the current value or current setting. The final setting on the first F4 screen, light control, shows that we are not controlling light relays in this case either. Page 2 has some similar information to page 1. It's our thermostat control, and again the use of the melt function. Page 3 shows us our settings specific to the thermostat control on evaporator A. So our control temperature and differential, which again correspond to the cut in and cut out that are used for the thermostat control. We are using sensor value to generate alarms for high and low temperatures. 100% value for the discharge air percentage indicates we're using S4 for our alarming. We'll wait for the asterisks to go away to update with the proper information. And you can see our high and low alarm set points and alarm delays here. The final screen in the settings options shows us our injection or superheat control set points for evaporator A. Here we can see injection control for the AKV valve is enabled. There are minimum and maximum superheat settings. So on this evaporator, we'll constantly try to maintain somewhere between 5.6 and 6.6 degrees of superheat. If we were to reach 2 degrees of superheat, the valve would close down immediately. There are no current manual values in for the AKV valve. We can then return to the main overview for this evaporator. Look at evaporator B. Here, we will again start with the measurements, F3. The regulating conditions would be the same information we saw in evaporator A. Here we can see the opening degree and the average opening degree on the AKV valve for this evaporator. So we would, just like evaporator A, we would cycle through the various screens to either get to a specific setting that we want to change, or under the F3 measures, view a specific sensor reading or relay condition. If we now back out of the view for evaporator B, we'll see we have two other options below that, the first being defrost. Again, we have F3 for measures and F4 for settings at the bottom. We'll look at the measures first. Here, some redundant information with the regulating condition for the two evaporators. We then see our defrost condition, so we are not currently in a defrost for any of the evaporators on this case controller. And then down below that information, we're given the sensor values on the defrost termination sensor. At this point, until we view the settings, we do not know if this is a sensor on the coil dedicated for defrost termination or if this is just a discharge air sensor. We'll go into the settings next to see which sensor is being used for termination. Below this information, we're given the time that the last defrost ran for before it was terminated on each evaporator, as well as the average defrost time each evaporator sees on all the defrosts it's run through. In addition to that information, we're also shown how long each evaporator typically takes to pull back down to temperature after the defrost is terminated. This information can be a good indicator of a problem on an evaporator or the valve of an evaporator when we see pull down times that vary by a wide margin from one evaporator to the next. If we then switch over to F4 for settings, we'll see our main switch is on, which is again an indication that the controller is running under its normal functions. We are controlling defrost, and we do have a dedicated relay with the control type being set to electrical. The defrosts are initiated from a schedule that comes from the 255. We'll go in and look at those schedules later. And our defrost failsafe interval here is set to 24 hours. So again, if the case controller has gone through a 24-hour period and has not seen a scheduled defrost or a manual defrost initiate on this case controller, it will automatically initiate one itself. Fans are turned off in this case when defrosts are running, and the termination method would be an individual sensor on each evaporator. We can see with the S5 option that indicates that we do indeed have a sensor that's dedicated on each evaporator to the coil for defrost termination, and based on that sensor reading during defrost state, we look for a 55-degree value to terminate. If we then return to the main overview for the 750, we can go into common functions. Common functions include information on anti-sweat control if we are utilizing it, light control, and door switch control. If we first click on F3 to view measures on the common functions, we again start off with the regulating conditions on each evaporator. We can see the status of the fan relay is on currently, and because we are not using anti-sweat control, our status is off. and we have no dew point or duty cycle percentages. In addition to this, we know from the setup that the lights were not being controlled either, so our light status is currently off. And our door switch is not set up, so any information under door status or related to door open times can be disregarded. If we click on F4, we then see the set points that are related to the common functions. Again, we are not using anti-sweat control here. So any settings related to anti-sweat control, including the day and night percentages, cycle time, or our range if using a dew point reading, are all irrelevant. We have no light control, and as mentioned before, we are not controlling anything based on the door switch. So any of the settings below this related to door switch control, refrigeration restarts, or door alarm delays are also irrelevant. If we then return to the overview of the 750, we can go back into the evaporator A section, and we'll look at the icons along the bottom of the screen. Our manual operation, or F1 option, will bring up a secondary window that allows us to manually initiate or terminate defrosts, and to manually override some of the other relay functions in the 750, including lighting relays, a shutdown of the 750 itself, as well as enabling or disabling the night setback schedule manually. To the right of the manual override functions, we have a camera icon, which is used to view history on the 750. This information can either be viewed in a graphical or tabular format. On this screen, we're giving 5 data points related to the 750. As you can see here, opening degree of the valve, temperature of the coil outlet sensor, superheat temperature based on the pressure transducer and coil outlet sensor, and then control temperatures on the evaporator. The select button at the bottom right of the screen allows you to choose from the various data points that are being logged for this 750. Up to 5 points can be viewed at any one time on this graph. The arrow keys next to snapshot will allow you to toggle back and forth in time to look at data over previous days, or snapshot back to the current data at this point in time. If we again go to the previous screen for the overview for evaporator A, we can then either hit the F2 button or click on the alarms icon. This brings us into an alarm menu where we can view active, acknowledged, or cleared alarms for this 750. Or we can go right into the alarm setup, which is the same screen we saw in the configuration of the 750. As we scroll through here, we can see we have high and low temperature alarms enabled for this case, as well as a control stopped alarm. For this alarm, anytime the main switch is turned off for the 750, an alarm will generate. The icon on the far right for configuration immediately takes us into the configuration screen where we initially configured all the set points for this 750. The final icon to discuss on this menu is our clock icon, which brings us to our schedules. Here you'll see our schedule management screen. There is an alternate way to get to this screen from the main menu of the 255. Proceed down to configuration on the bottom right. and you'll see a schedules option. This will take you to the same screen. Here you can configure schedules for defrost, lights, and night setbacks, all related to 750s. A common schedule can be shared between multiple 750s if desired. In this case, we'll start by viewing the case light schedule. Here you can see for schedule usage, you must determine ahead of time what this schedule will actually be applying to, and then based on that decision, you'll have different parameters to set for the schedule. We give it a description, and then we determine what our schedule control will be based on. It can either be based on a timed schedule, which will be set on the next page, or it can be controlled based on a digital input of some sort, which is tied back into the 255 itself, not into the 750. We also have options to use a combination of the two, where time and digital input requirements must be met, both together before the schedule would become true, or a combination where either of the two functions would allow the lights to come on. Once we've enabled this schedule, we set up how many time periods we actually want to toggle the lights on and off, and then we page down to the second page where we can see start and stop times of all zeros indicate a 24-hour schedule for the lights for these cases. Here we can also enable and disable specific days of the week. And any holiday schedules that have been set up in the store info section of the 255 can also be applied to the case controllers here. Once the schedule has been set up, we then return to the first screen for the schedule, and we'll click on the controllers button in the bottom right corner. Here is where we choose which 750s we want to apply this schedule to. Any 750 in the list that will use the case lighting schedule will have an X and checkbox under the select column. Any cases not using this schedule will be disabled and have no X. By highlighting the box and hitting the Enter key, you can enable and disable schedules. Keep in mind, if multiple lighting schedules are configured, a case controller can only have one schedule assigned to it. By assigning a schedule to a case controller in one schedule, you are at the same time disabling another schedule that may be assigned to the case controller as well. If we then back out to the main overview for the schedule management, we'll see a status update on that schedule, and because we were set up for a 24-hour time period, our current status is true. If the time period was only a small portion of the day and the current time in the controller did not match a time for one of those schedules, your status would reflect that and show false here. We'll next look at a defrost schedule that's applied to one of the case controllers that we're using. Here we'll go into the A3 defrost. Again, our schedule usage here has defrost selected, so you'll notice there are different options below that because of that choice. We do have similar options for time or digital input control of the defrost. And once we've enabled this schedule, we have the option to use an auto stagger, which will automatically stagger all your defrost schedules in the schedule management section of the 255 so that they're spaced out evenly for the rack. And with that option either enabled or disabled, we can then program in the number of defrosts each day. As we page down to the second page, we enter in our individual times for each defrost. If the auto stagger function is being used, you will not be able to individually set each defrost time on the 750. Once times have been entered in, we'll again click on the controllers option. And for any case controllers we wish to apply this defrost schedule to, we'll make sure there's an X in that box under the select column to apply the schedule to that circuit. If we return to the main overview for the schedule management screen, we can see for each defrost there's a timestamp under the status column, which gives us an indication of when the last defrost signal was sent to the 750 case controller from the 255 schedule. If we then look at our third type of schedule input, or shutdowns, we can see under schedule usage we've selected shutdown. And in this case we're using only a digital input for control of the shutdown of the case controller. There is no schedule in relation to time that is being used to shut it down. Although you can see we do have an option to add in a time schedule for shutdown if desired. We then select the digital input, which has already been programmed into the controller under the miscellaneous section. We program in any pre or post delays to delay the shutdown of the case controller after the digital input has closed, if desired. We'll again click on the controllers option in the bottom right and make sure that this schedule is only applied to the case controllers we want it for. Back on the main overview for the schedule management, we see the status column gives us a current indication of whether the shutdown input is on or off based on a true or false value. True would indicate the case controller is currently in a shutdown state. False indicates it is not in a shutdown state.